Uh, Welcome everybody. We'll start today's discussion on some of the questions from your daily quiz, which were asked in first week of May from mathematics course. Okay. So there are I think around 6 questions in this quiz. So we'll solve them one by one. Major focus is on calculus, but I think there are certain other questions also. So we'll see. Okay. So let's see the first question. This is a question based on the limit, and if you don't know the limit, every year they ask at least one question from this. So it's a very important topic. And in limits also, the L'Hospital's rule, which is applicable for 0 by 0, infinity by infinity forms, all those kind of things. And that is, this question, first question is also based on the same thing only. So here you're supposed to evaluate two limits, and their values are equal to a and b. And finally, you're supposed to give the answer, which is a minus 2b. Okay, so that is the question here. Now let's evaluate each limit one by one. Okay, so let's take the first one. So it is limit extending to 0 plus. That means approaching 0 from the positive side of real line. Okay, x square ln 4x square. Okay, so the reason why they are mentioning it is to be extending to 0 plus is because if you look at a plot of your log function, usually it is, let's say this is your x and this is y. So this is your y equal to log of x. You can take any base. This is natural base log. So it is usually, as x tends to 0 plus, the log function tends to minus infinity. Okay. Because it is not defined for exactly 0 or negative values of x. Okay, so therefore, y equal to ln function tends to minus infinity. Okay, so that is why they are writing it as x is tending to 0 plus. Okay. So after that, the rest of it is straightforward. So let's say we are evaluating the value of a. Okay, so a equal to limit x tending to 0 plus x square into ln of 4x square. Okay, so if you just put x equal to 0 here, x square term goes to 0, whereas this log function is nothing but log of 0, so that tends to minus infinity. So you cannot solve this in this form because you are not getting any conclusive answer or finite answer. So one thing is to convert this into infinity by infinity form or 0 by 0 form. Okay, so what you can do is limit x tends to 0 plus, keep ln function in the numerator, and x square, which was multiplied earlier, take it in the denominator and write it as 1 by x square. So if you do that, what happens? Your numerator turns, this is infinity or minus infinity for that matter, but doesn't matter because we are basically going to use L'Hospital's rule, which is applicable for infinity by infinity. So numerator tends to unbounded infinity value, albeit the negative sign, and 1 by x square is 1 by 0, that also goes to infinity. So this is now solvable using L'Hospital's rule. Again, those who don't know, L'Hospital's rule is basically keep on differentiating numerator and denominator both till you get a finite answer. Let's do that. Differentiation of ln 4x square is 4x square into 4 into 2x. Okay, so this is a chain rule of differentiation, and this is x power minus 2, so differentiation will be minus 2x power minus 3 in the denominator. Okay, so from numerator 4 gets cancelled, 1x also gets cancelled, this 2 also gets cancelled. So what you are left with is basically a equal to limit x tending to 0 plus, there is one x power minus 1 in the numerator, 1 by x is x power minus 1, and in the denominator you have minus x power minus 3. Okay, everything else gets cancelled. So this is basically equal to limit x tending to 0 plus minus x square. Okay, and x, if you put 0, this value, the limit value comes out to be 0. So therefore your a is 0. Okay. Now let's evaluate the second limit because finally we want a minus 2b. So let's evaluate this limit. So b is limit extending to minus infinity x square by e to the power minus 2x. Okay. So your b is limit extending to minus infinity x square divided by e power minus 2x. Okay. So now, as x tends to minus infinity, your numerator is x square. So it will go to infinity. Okay. And what happens in the denominator? X is minus infinity. So this becomes e power minus 2 into minus infinity. So that is e power 2 infinity. So that is also exponentially increasing function. So this is now in a infinity by infinity form. So we use L'Hospital's rule to solve this. And as I told you, just keep on differentiating numerator and denominator both till you get a finite answer. So numerator differentiation is 2x. Denominator e power minus 2x remains as it is, and then minus 2 comes because of minus 2x term. Okay, chain rule of differentiation. So here 2 gets cancelled, and what you are left with is limit extending to infinity minus x by 2 into e power 2x minus 2x. Okay. Now this is also infinity by infinity because x also tends to infinity. The denominator term is same as the first equation, so it is also going infinity. So you have to again differentiate or use L'Hospital's rule one more time. So if you do that, what do you get? Limit extending to minus infinity. Differentiation of minus x is just minus 1 divided by 2e to the power minus 2x, that is, and then minus 2 will come. So 2 into e power minus 2x into minus 2. So it is basically limit extending to minus infinity. So minus minus goes away. So basically you have 1 by 4 e power minus 2x. Okay. So now you cannot differentiate the numerator further. But if you look at this, if you put x equal to minus infinity in the denominator, that goes to infinity. So basically it is 1 by infinity. So here b is nothing but b value. So b is nothing but 1 by infinity. So basically b is also 0. Okay. So a is 0, b is 0. Therefore a minus 2b is also 0. Okay. This is your answer, final answer, what they are asking you to find. Okay. So if you go back to the question, yeah, option A should be the correct answer. And yeah, that is the correct answer also given in the answer key. Okay. So this is the classic problem which is expected from you also, because this is very important for your GATE exam. Okay. L'Hospital's rule, at least one problem you can expect. Okay. That has been the historical trend for most of the branches. Now let's move on to the second question. So this is the function f of x, which is 1 plus mod of sin x. Now they are asking you about continuity and differentiability of this function. But the only point of contention here is how to analyze mod of sin x. Okay, so we had seen this in our regular classes under the name of graph transformations. Okay, so basically everybody knows how to plot y equal to sin x. Okay? And the plot typically, it is like this. It goes to 0 at 0 minus pi plus pi, and it continues like this on both the sides of these limits. Okay, but the thing is, when you have y equal to mod of sin x, so that is a slightly different case, because mod always gives you positive values. Okay, so whenever your sine function is positive, nothing changes there, it remains as it is. So from 0 to pi it will again be positive value, but after pi, when the value was going into this negative direction, that will also go like this. Okay, and it will be always positive because mod function is always positive. Same thing happens on the other side also. Okay, so you will not have any negative sign basically. And if you plot y equal to 1 plus sin x, oh sorry, I'll use the other color for this. so that it is easier to bifurcate. So what they are asking in this question is 1 plus mod sin x. So nothing changes here. The whole mod sin x graph shifts by 1 unit. Okay, so let's say this is your 0, this is your 1. So the same plot will shift by 1 unit up. Okay? So it will look something like this. So this will be your pi, 2 pi, and so on and so forth. Same thing happens on the other side also. This will be your minus pi, minus 2 pi. Okay? So basically this is the plot that you are supposed to envision when these kind of questions are asked. And we had discussed this extensively in our regular classes. So those who had attended seriously would have solved this question without any problem. So now what they're asking is about the continuity. So you can see clearly from the graph whether, my drawing is not proper, but this is continuous graph, right? For any value of x, like any interval of x value, there is no discontinuity. Okay. So therefore, the first option is not correct because it is continuous everywhere. So option B is correct. Now they are talking about differentiability at x equal to 0. And since we are solving it graphically, you should recollect wherever you have sharp bends in your curve. So at x equal to 0, you can pay attention. The curve has a sharp bend. Okay. So therefore, it is not differentiable at that because the slope changes. Okay. Sharp bend or turn in graph at x equal to 0. Okay. So therefore, it is not differentiable at x equal to 0. Okay. And the last option is asking at not differentiable at infinite number of points. That is true because at pi also there is a sharp change in the slope or sharp turn in the curve. Similarly, going minus pi, minus 2 pi. So there are infinite number of points of non-differentiability. This is correct because those points are x equal to n pi. Okay, and n goes from minus infinity to infinity, but only integers. Okay, so therefore there are infinite number of n values for which it is non-differentiable. Okay, so option B and D are correct options. Okay, so that is the correct answer. Okay, so this was very good question which you could have solved easily using graph, but it is difficult to solve it analytically because in the last option they are talking about infinite number of discontinuities, etc. See, analytically you can verify at x equal to 0. That is fine if you don't want to go graphical way. But how will you verify option D? That's difficult to do it analytically, and that's why you need to take the help of graphs. Okay. So this is a classic question. So apart from this, this is y equal to mod of fx plot. There are y equal to f of mod x, y equal to mod of f of mod x. Okay, so there are 3 cases where you take mod sign and see the change in the plots. Okay, so we have discussed in the regular class. You can revise those things. Okay, because if you know these transformations, these are pretty straightforward questions. But if you don't know, it will take a lot of time for you to solve this kind of questions in your exam. Let's move on to the third question. In this question, basically this is integration question, and that is also from the definite integral topic or definite integration topic. And they have given you additional information that f of x plus f of pi minus x is pi square. Okay, so with that information, you're supposed to solve this integral. So let's go to the next slide and try to solve this, because here we use, see, there are some 5 to 6 properties of definite integral, okay, that you are supposed to remember for your GATE exam. And we are using, one of those property, okay, which is nothing but if you have, let's say, definite integral between limits a and b, f of x dx, it will be also equal to f of a plus b minus x dx. So wherever you have x in your function in the integral, you are supposed to replace it by sum of the limits minus that x. Okay, and we use this property here. So therefore, what happens? Your integral I becomes 0 to pi. Limits remain as it is. It will be pi minus x and sine pi minus x, because the sum of the limits is 0 plus pi, that is just pi. And we know the property of sine function that, uh, Sin pi minus x is sin x. Okay. If you don't know this, you should revise your sin a plus b, sin a minus b, cos a plus b, cos a minus b, tan a plus b, tan a minus b formula. Okay, because those are expected from you. That is underlying assumption that you know those things. So now let's say this is your equation 1 and this is your equation 2. So add equations 1 and 2. So what happens on the LHS, you have 2i. Basically you add 1 and 2. Why do we do that? Is because we need to use the given information. So LHS becomes 2i. And since the integral is a linear operator, this becomes f of x sin x plus f of pi minus x sin x whole dx. Okay. So, you can take sin x common from both the terms. And this will become f of x plus f of pi minus x into sin x dx. Okay. And in the question, it is given that this summation of two function values is pi square, which is a constant. Okay. So therefore, it comes out of the integration sign. And, basically you are supposed to evaluate this integral, which is nothing but sin x dx between 0 to pi. Okay. So, we all know that it is standard formula. Cos differentiation is minus sign, so therefore sin integration is minus cos going from 0 to pi. So let's take the negative sign out. Cos pi is minus 1 minus cos 0 is plus 1. Okay. So therefore this is minus 2 and this LHS is 2i is equal to minus pi square into minus 2. So that is 2 pi square basically. Negative sign minus minus is plus. So 2 gets cancelled and therefore your integral value is pi square. Okay, and this is your final answer. So what is the correct option in this context? Yeah, option A is the correct answer. And that is also given in your answer. Okay, so this is one of the application of properties of definite integrals. Okay, because if you don't recollect this, you can't solve this problem basically. Even with the options given, it's not possible. Okay, so that's why those properties are very important. And you can, after this you can revise those if you want. Now let's move on to the fourth question. Okay. So here they have given you an f of x function, two-part definition of this. It is for greater than or less than or equal to 5. There is another definition for greater than or equal to 5. Another definition. A and B are unknowns in this definition. Additional piece of information is it is continuous at x equal to 5. Okay. And now they are asking you finally to find a minus b. So let's do that. The crucial piece of information here is, this given f of x is continuous at x equal to 5. Okay. So what does that mean? That means limit extending to 5 minus f of x should be or must be equal to extending to 5 plus f of x equal to f of 5. Okay. In our regular classes, we call this as LHL, left hand limit. This is RHL, right hand limit, because you approach from the right hand side of 5. Okay. And this is your actual function value. Okay. At whatever point that is under the contention. So here we are evaluating the limit at x equal to 5 because there only the definition of function is changing. Okay, that is why we are doing this. So now let's evaluate LHL or this first limit. So when you are approaching x from the minus 5 side, that means you are supposed to use the first definition. Okay, so that will be limit extending to 5 minus only minus a into pi minus x plus 1. That is a mod pi minus x plus 1. But now if you put x equal to 5 here, pi minus 5, see pi value is approximately 3.14. So that will be negative. So since it's a mod sign, the final answer will be positive. So therefore, you can just write it as 5 minus pi plus 1. Okay. So let this be your equation 1. Okay. And now let's evaluate the right hand limit. Okay. And see whether do we get something out of this. So 5 plus, that means you have to use the B definition. So that is nothing but B x minus pi in mod plus 3. Okay. And now if you just put x equal to 5, 5 minus 5 will 5 minus pi will be some positive number. Okay. So therefore you can just write this limit as b into 5 minus pi plus 3. So let it be equation 2. And these two, equation 1 and 2, they are same because of the continuity property. And now what they're asking in the question for you to find is a minus b. So the easiest way to do this is, what you can do is, see, you have this from 1 and 2. What you can write is a into 5 minus pi plus 1 is equal to b into 5 minus pi plus 3. Okay. And this is very important step. If somebody is getting confused here, you can go back and revise your modulus properties. Okay. Because if you understood that part, the rest of it is easy. And now since we are interested in a minus b, I'll take b into 5 minus pi on LHS. So this will be, or RHS basically. We are interested in what? A minus b, right? 1 second. Yeah. So let it be in this fashion. Okay, so 5 minus pi is common in the both terms. And then RHS will be 3 minus 1, that is 2. Okay, so therefore a minus b turns out to be 2 by 5 minus pi. And are they asking us to calculate this? No. Okay, so 2 by 5 minus 5. So that is option D, no? Yeah, that is also given in your answer key. So, this was a straightforward question where you are supposed to use the continuity properties of right hand limit equal to left hand limit equal to actual function value at that point. Okay, and one small tidbit of
You are currently the only person in this conference.
Yeah, one small piece of information about mod function. Okay. So if we had known these two things, you should be able to solve this problem. Okay. Now let's move on to the next question. Okay, so this is also a limit question, but now this z is a complex number. First of all, you should understand that. Okay, what it is we don't know, but in the limit it is approaching 1 plus I. Okay, usually z is written as x plus iy. X is the real part, y is the imaginary part. See, the calculation, to determine whether the limit exists for complex functions is not that easy. Okay, we have seen this in our regular classes. But in this question, they are saying the limit value exists because all 4 options are non-zero. So you don't have to worry about whether the limit exists or not. What you have to worry about is this part. Okay, this is not a single option correct question. There could be more than one options correct. So let's solve it, because since they have given you finite options as the finite values as the option, that means the limit will exist for this complex function. And now let's put this z value in this limit and see what happens, because if it is coming 1 by 0 or 0 by 0 or something like that, then we are stuck. But let's check whether it's finite limit or not. So if you put z equal to I plus 1 or 1 plus I, you have I in the numerator and you have I plus 2 in the denominator. So this is a finite value, okay, in the complex plane, obviously. But there is no option like that. So the common trick used in these kind of situations is rationalize the numerator as well as denominator. Okay. Why do we do that? Because then you get a square minus b square formula. So in the numerator you have I square minus 2i divided by I plus 2 into I minus 2 is I square minus 2 square. Okay, so we all know I square is minus 1. This is minus 2i divided by I square is again minus 1, and you have 2 square is 4. Okay, so basically in the denominator you have minus 5, so that negative sign gets cancelled from both the sides, and you have 1 plus 2i divided by 5. Okay, yeah, that is the first option. Okay, second option cannot be true because it's same as the first option, only the sign is negative. Okay, then there are C and D options, because as I told you, most of the people will make mistake here. Just tick the option A and move on, but this is multiple option correct. So now see, the next hint is C and D has 5i in the denominator. So what you can do is you can multiply, this limit. Okay, what you have is 1 plus 2i by 5 now, and in option C and D that is 5i in the denominator. So what you can do, multiply and divide by I to the numerator and denominator. Okay, so this is 1 plus 2i. Okay, and you just multiply by I and divide by I. So what you will have, I plus 2i square divided by 5i. Okay, again I square is minus 1, so this will become I minus 2 divided by 5i. And if you look at the options, yeah, this option is correct. This cannot be correct because if C is correct, D cannot be correct. So that's why options A and C should be the correct answers for this. Yeah, that is correct. Okay, so this was one simple question of limits of complex functions. And the fortunate part was the limit was coming out to be finite. So we did not have to do much thing, because otherwise the question would have been very difficult to solve. Okay. Anyway, so we had discussed about the limits of two function variables, how to calculate those limits of complex functions and all analytic functions. Okay, so you can revise all this concept as well along with this. So this is your last question. So in this question there are two constants m and b, so that the function y, which is also a two-part defined function, and it is differentiable at x equal to pi. Okay, so again differentiability definition is left hand derivative should be equal to right hand derivative at x equal to pi. Okay, that is the basic thing that you can guess, because here there are two unknowns m and b, so we need two equations to solve them, right? So let's use this information that it is differentiable at x equal to pi, and let's calculate left hand derivative and right hand derivatives at x equal to pi, okay, for this function. So left hand derivative for this function will be nothing but the derivative of this function approaching the left hand means you are approaching x from pi minus. Okay, so in that context, what is the definition of this function? Slightly less than pi, that is sin x. Okay, so left hand derivative will be nothing but derivative of this function value or function definition for x tending to minus pi, and that is just sin x. So derivative of sin x is cos x. Okay, but you need to evaluate this, no? See this value at x tending to minus pi minus, right? So basically you have to put cos equal to x equal to pi here. So what is the cos pi value? That is minus 1. Okay, therefore your left hand derivative is minus 1. Okay, and similarly you can find the right hand derivative, that is basically meaning x tending to pi plus. So you are approaching pi value from the positive side of real line, and if you do that, the definition is mx plus b. Okay, so you have to differentiate it. Okay, and if you do that, what do you get? You get just m. Okay, and it's a constant, so you can't put x equal to pi here. So from this, m has to be minus 1. Okay, so you got one unknown from using the definition of differentiability. So m has to be minus 1, so that means C and D are not correct. Now the fight is between first and second options, but now we have used the differentiability condition, so what to do for D? Okay, and that is when the knowledge of these concepts come into the picture, because if f of x is differentiable at x equal to pi, it also must be continuous at x equal to pi. Okay, because that is the underlying condition, because if the function is not continuous at that point, it is definitely not differentiable. Okay, so therefore again we'll use the left hand limit equal to right hand limit equal to the function value at pi. So this condition comes from the continuity. Left hand limit is nothing but limit extending to pi minus function value is sin x, right? So that is sin pi, basically it is 0. Okay, and right hand limit is nothing but limit x tending to pi plus mx plus b. So x has to be equal to pi, so this is m pi plus b. Okay, so from this two you can write m pi plus b must be equal to 0. Okay, and that gives you b equal to minus m pi. Okay, and we have already seen uh, m is minus 1, so therefore b will be minus minus plus pi. Okay, since m is minus 1, so that means b has to be pi. So if you go to the options, option b should be the correct answer. Yeah, that is also given in your answer key. Okay, so here we use the concepts of differentiability and continuity together. Okay. So this is the end of your questionnaire for this quiz. Okay. So with that we'll stop here and see you in the next video. Okay, bye.